Hi, welcome back. This is Professor Ridge. Today's lesson is on section 3.2, quadratic equations, functions, zeros, and models. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals to 0, provided a is not equal to 0. Okay, so you don't want that first term to cancel out. The x squared is what's making it quadratic. And a, b, and c are real numbers. Okay, so that's a quadratic equation. Now, a quadratic function is pretty similar. A quadratic function f is a function that can be written in the form, and we're just going to use function notation. F of x is equal to, and then it's the same idea, ax squared plus bx plus c, and provided a is not equal to 0. Again, because if a is 0, then the x squared term would go away, and then it wouldn't be a quadratic function anymore. And again, a, b, and c are real numbers. A quadratic equation written in the form ax squared plus bx plus c equals 0 is said to be in standard form. Okay, so when we write it that way, in descending order, ax squared plus bx plus c equal to 0, that's standard form. Now we're going to be using this word 0 a lot. So the zeros of a quadratic function, f of x equals ax squared plus bx plus c, are the solutions of the associated quadratic equation ax squared plus bx plus c equals 0. So basically we're saying, what for a function, what x value do you plug in to get 0? So that's why it's called the 0 of the function. So basically if you take the function ax squared plus bx plus c and set it equal to 0 and solve it, that x value will give you the 0 of the function. Okay, so that's the terminology. And sometimes we say solutions to this equation. Sometimes we call it roots. Okay, let's review some equation solving principles that we learned in previous algebra classes. So the principle of zero products, and basically what it says is if you have a times b equals 0, so that's a product, two numbers multiplied together equal to 0, if that's a true statement, then the only way you can get 0 is either one of the factors have to be 0. So either a equals 0 or b equals 0. And it works, the converse is also true. So if a equals 0 or b, if a equals 0 or b equals 0, then the product AB has to be 0. Okay, so that works both directions. The technique that we use for solving quadratic equations is the principle of square roots. So if you have x squared equals k, then you can square root both sides. So x equals square root of k, or x equals negative square root of k. Okay, so those are principles that we use to solve quadratic equations. All right, let's try a few just to jog our memories. Okay, solve x squared plus 6x plus 8 equals 0. So this one, I'm going to, I want to use the zero product principle, and to be able to do it, I have to write it as a product. So to write as a product means you're going to factor, and it has to be equal to 0, which it already is. So I want factors of 8 that add to 6, factors of 8 that add to 6. So that's 4 and 2. Bigger one's positive. They're both positive to get positive 8. And now I met the first part of the principle of zero products. I have A times B equals 0. So that tells me, if that's true, the only way that can be true is either x plus 4 equals 0 or x plus 2 equals 0. And then you just solve those individually. So x equals negative 4 or x equals negative 2. So you get the two solutions and you're done. If you want to write it as a solution set, use braces because they're individual numbers. It's not an interval. It's just two individual x values. Okay, let's try another example. 5x squared plus 10 equals 0. Now if there's no middle term, we'll use the principle of square roots. We want to get the x squared by itself. So subtract 10 from both sides. Then divide both sides by 5. So we get x squared equals negative 2. And then we can apply the principle of square roots. So we square root both sides. So x equals square root of negative 2, or x equals the opposite of square root of negative 2, or negative square root of negative 2. And again, we want to simplify these. So from what we learned in 3.1, this is an imaginary number, so we pull out the square root of negative 1, which is I, square root of 2, or x equals negative I, square root of 2. That's our answer. So we get I square root of 2. Well, let's put the negative 1 first. Now some people put the I afterwards, some people put it before. Me personally, I like it before, so that way you don't confuse that it's under the square root or not under the square root. Okay, so that's using the square root principle. Okay, and then the next technique we developed was completing the square. So let's try one of these where you have to complete the square. Actually, before we solve one, let's just talk about completing the square. So now, if I did a plus b squared, that's going to be a squared. And remember, it's a plus b times a plus b. I FOIL it, so it's a squared plus ab plus ba, which is the same thing as ab. So you get 2ab. And then plus b squared. Okay, and then if it's the middle term's minus, then it's minus 2ab. Alright, so if I wanted you to do x plus 3 squared, you're going to do x squared plus 2 times x times 3, which is 6x, plus 3 squared, which is 9. If you do x plus 4 squared, it's x squared, plus 2 times x times 4, which is 8x, and then 4 squared, 16. X plus 7 squared, the x squared, plus 2 times x times 7, that's 14x, plus 7 squared is 49. Now, so the idea, if we look at all these problems, if I want to go backwards, so if I have x plus blank squared equals x squared plus, say, 20x plus blank, and I want to go backwards, then the idea is, well, let's see, if I'm going, let's look at the x plus 3. To get this middle term, 6x, I do the x times 3, the x times 3 times the 2 to get 6x. So if I'm going to go backwards, I'm going to divide this 6x by 2 and get 3x, and then just split up the x and 3. Or just just take the 6 divided by 2 is 3. And notice that works for all of them. 8 divided by 2 is 4. 14 divided by 2 is 7. So we're going to take the 20 divided by 2, and that's 10. And then to get the last term, you do 10 squared, and that's 100. And that process is called completing the square. Okay? So, if I want to solve an equation by completing the square, okay, let's look at x squared minus 10x minus 22. So again, if I want to complete the square, what my first step is, I'm going to get rid of the constant term, put it to the other side. So add 22 to both sides. And I'm going to leave a blank here, plus a blank here. And so I'm going to complete the square with those two things. So basically, it's like the one I just did above, except it's a minus instead of a plus. Oh no, it's not. Alright, so what's the process? So if I want to do, I'm going to take the middle term, divide it by 2, which is 5, and then I'm going to take that 5, square it, which is 25, and you know what golden rule, what you do one side, you got to do the other. So we add 25 to both sides. And then we simplify. 22 plus 25 is 47. Okay, so that's the key step, completing the square. Now we're going to view this parentheses x minus 5 as just something squared equals a number. So now I'm going to use the square root principle and square root both sides. So normally I wouldn't show this. So I'm going to square root both sides. Don't forget the plus minus. So we get that x minus 5. The square root cancel each other. So you just get x minus 5 equals plus or minus square root of 47. And then we want to get x by itself, so just add 5 to both sides. And since 5 and square root of 47 are not like terms, can't combine them, so we just write them down. 5 plus or minus square root of 47. And don't forget, that's just shorthand for 5 plus square root of 47, comma, 5 minus square root of 47. So if I write it in set notation. Okay, so that's completing square. Let's try a couple more. So let's solve 3x squared plus 6 equals 10x, and again we're going to use completing the square. So what I want to do is I want to subtract 10x. I want to get the constant on the other side, so leave some space. Now I'm going to complete my square. Oh no, first. Okay, so I don't need the first thing I want to do is all the things I've done so far is I want x squared. So let's ignore this for a moment. So we get x squared minus 10 thirds x. Now I need the space. Negative 6 divided by 3 is negative 2. Now I'm going to complete the square. Okay, so I'm going to take half the middle term. So 10 divided by 3 divided by 2 is the same thing as times 1/2. So that will be 5 thirds. Negative. 5 thirds squared, you square the top, square the bottom, add it to both sides. Okay. Now we're going to let's see, negative 2 over 1 plus 25 over 9. You got to get ninths, so this one will be negative 18 plus 25 is 7 ninths. Okay, and then we're going to square root both sides, so x minus 5/3 equals plus or minus square root of 7 ninths. And then we're going to add the 5/3 to both sides and simplify square root of 7 ninths. So it's square root of the top divided by square root of the bottom. So that's our final answer. If you want, you can make that one fraction since you got common denominators. So you can write 5 plus or minus square root of 7 all over 3. So either way. Okay, so that brings us to the quadratic formula. And after doing several of those completing square problems, you get the sense that, you know what, let's do it, let's follow that exact same technique in general. We'll just put letters in here and see what happens. So we're going to get rid of the constant. So I'm just mimicking the steps I just did in that example above. I'm going to divide all the terms by a because I just want the x squared plus b over ax plus blank equals negative c over a plus blank. Now we're going to complete the square, so you take half the middle term, so b over 2a. So remember, dividing by 2 is the same as multiplying by 1/2. So b over a times 1/2 is b over 2a. And we're going to square that, so it'll be b squared over 2a times 2a is 4a squared. Golden rule, what you do to one side, got to do the other. Okay, now the hardcore math part here is we got to do negative c over a plus b squared over 4ac, a squared. We want common denominators, so we need to multiply the c over a by 4a over 4a. So we get negative 4ac over 4a squared. And now we have common denominators. So, and then we'll put the b squared in front. So it'll be b squared minus 4ac over 4a squared. Okay, now we're ready to do the square root principle. Square root both sides. X plus b over 2a equals plus or minus square root of b squared minus 4ac over 4a squared. Now we're going to take the square root of the top, which you can't simplify, and then the square root of the bottom, which is, we'll first subtract b over 2a from both sides. Again, we're going to take the square root of the top, which is b squared minus 4ac, which you can't simplify. Square root of the bottom, well, you can simplify that to be 2a. And again, you got common denominators, so we make this one big fraction. It's the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. And this is the quadratic formula. So we erase all the work in between and jump to the answer in the last line. So the solution to, so let me write it here, the solution to ax squared plus bx plus c, now it has to be in the standard form, is that box there. So that's the quadratic formula. So we want to memorize that formula. Okay, let's try an example. 5x squared minus 8x equals 3. I'm going to solve it. So our first step is put it in standard form, so get it equal to 0. So subtract 3 from both sides. And now we have a equals 5, b equals negative 8, and c equals negative 3. And we plug it into the formula. So x equals the opposite of b plus or minus square root of b squared, which is 64, minus 4 times a times c. So it's 4 times 5 times negative 3, which will be 2060. Negative and negative make positive 60. All over 2a. 2a is 2 times 5, so that's 10. And then we just got to simplify that. So that's going to be 8 plus or minus square root of 124 all over 10. Now, of course, we got to simplify the square root. I mean, that's the exact answer, but we want to simplify it. So x equals 8 plus or minus square root of 124 over 10. So let's note 124. We want to factor that, so that's going to be 4 times 31. So a 2 is going to come out. 2 square root of 31. And then we can factor, since we have an 8 and a 2 and 10, 2 divides out of all 3 of those, so we divide it out of all 3 of those. Or you can think of it as you're going to factor a 2 out of the top. 1 square root of 31. And then 10 is 2 times 5, so you see the 2's cancel. So remember, when you reduce a fraction, you have to factor and cancel common factors. So x is 4 plus or minus square root of 31 over 5. Alright, so now let's talk about the discriminant. So the discriminant is basically in the quadratic formula. It's the thing under the square root, the b squared, the radicand, b squared minus 4ac. And basically that's going to tell you what type of solutions you're going to have, because if this, see up here, the 4 plus or minus square root of 31, if that radicand was something nice, like 16, a perfect square, square root of 16 is 4, and then I get 2 rational answers. If the square root of 31 doesn't simplify, so you get an irrational solution. If that radicand was, say, square root of negative 5, then you would have an imaginary number. So the radicand, the radicand is called the discriminant, b squared minus 4ac. Okay, so the discriminant, b squared minus 4ac, again, that's the discriminant. If it's equal to 0, you're going to get one real number solution. And just a little more information, it's going to be a rational number. So it's going to be something nice. It's going to be a fraction or a whole number, but it's no square root. The square root goes away, because square root of 0 is 0. If the discriminant's greater than 0, so if it's positive, that means you're going to get 2 different real number solutions. And we can know a little more. If it's positive and it's also a perfect square, then it'll be rational. If it's not a perfect square, like the one we did above there, it'd be 2 different irrational solutions. So you can actually go a little deeper. The book's just stopping here. So that's all I'll say. And then if the discriminant's negative, then that's going to tell you you're going to get 2 imaginary solutions. They happen to be complex conjugates. Okay, so if you have an imaginary solution, they always come in conjugate pairs. Complex conjugates. Alright, so find the discriminant, determine the number and type of solution, or solutions. So if I had something like 4x squared minus 12x plus 9 equals 0, So it has to be in standard form, so if it's not, you put it in standard form. And then the discriminant is just the b squared minus 4ac, which in this case is the opposite. I mean, that's negative 12 squared minus 4 times a is 4, c is 9. So it's 144 minus, is that 144 too? Yeah, it is. So that is 0. So you look at your chart up there, b squared minus 4ac equals 0, so that tells me that we have one real number solution. And that's all you do. Okay, so you'll have a few of those questions in the homework. Alright, so the last thing in this section I'm going to talk about is equations are reducible to quadratics. So if I asked you to solve the equation x to the 4th minus 3x squared plus 2 equals 0, it's not a quadratic equation, but it behaves like one, because I can think of it as this is x squared squared minus 3x squared plus 2 equals 0. So if I if I notice I have 1, 2, 3 terms, and I have something squared minus 3 times that same thing, that parentheses, plus a constant. So this has the same behavior as the x squared, even though it's a 4th. So what I do is I'm going to do what's called a u substitution. Let u equal x squared, and you're going to substitute it in. So we're going to get x squared squared is x to the 4th. So we're going to get u squared minus 3u plus 2 equals 0. Okay, so let me rewrite that over here. U squared, so we're going to let u equal x squared, and we plug it into the equation. So we got u squared minus 3u plus 2, and see, now it's a quadratic equation. So I'm going to solve it. Factors of 2 that add to 3. So that'll be negative 2 and negative 1. Set each of those equal to 0. Solve it. So u equals 2 or u equals 1. But we're not solving for u, we're solving for x. So now you're going to substitute back. So we get x squared equals 2, or, because remember, u equals x squared, so we're going to replace u with x squared. X squared equals 1. And here I'm going to use the square root principle, so x equals plus or minus square root of 2, or x equals plus or minus square root of 1, which is just 1. Okay, so we have 4 solutions. We have negative square root of 2, negative 1, 1, square root of 2. Okay, so it has 1, 2, 3 terms. It has the potential to behave like a quadratic equation. So as a rule of thumb, I always tell my students, look at that middle term, just the variables, m to 1/3. If you let that be your u, and then square both sides, you get u squared equals, what's m to the 1/3 squared? So that's m to the 2/3. And you look, the middle term's m to the 3rd, so that's going to be u, and if the first term is the square of that, see, m to the 3rd squared is m 2/3, then we're in business and we can do this substitution. So we're going to let u equal m to the 3rd. So over here I was just checking to see if it'll work. Okay. Check to see if it works. if it fits quadratic. Okay, so we got u squared minus 2u minus 8 equals 0. Factor it if you can factor it. If not, use quadratic formula. So let's see, we got u factors 8, subtract the 2 is 4 and 2. Bigger one's negative, signs are different. So u minus 4 equals 0, so u equals 4. Or u plus 2 equals 0, so u equals negative 2. And again, we're solving for m, not u, so you got to substitute back. M to the third is 4. M to the third is negative 2. And then the way you solve that is you cube both sides to get m by itself. So it's because we want m to the first, we want just m. So the cube root of m, you cube both sides, you get m equals 64. Cube both sides, and you get m equals negative 8. So 64 or negative 8. Okay, so let's try one more. And the key here is look at this parentheses. They're the same. Oops, there should have been a square there. So we're going to let u be that parenthesis. Let u equal the parenthesis. 2t squared plus t. So we're going to get u squared minus 4u plus 3 equals 0. Factors of 3 that subtract or that add before. So it's 3 and 1. They're both minus. So u equals positive 3 or u equals positive 1. So I skipped those couple steps. Hopefully that wasn't too much for you. Remember, you set them equal to 0 and then you solve them. And now we got to substitute back. U is 2t squared plus t equals 3. So 2t squared plus t equals 1. And now we got new quadratic equations, so we got to solve those. So 2t squared plus t minus 3 equals 0. That one factors. So we got 2t. T factors, so it's 3 and 2. And I want positive 3, negative 2. So we're going to get t equals 2t plus 3, 2t plus 3 equals 0. So t must be, you're going to subtract 3 and then divide by 2. And t minus 1 equals 0, so t equals 1. And then over here, same thing, 2t squared plus t minus 1 equals 0. I'm going to factor it. So we get 2t, t, 1 and 1. We want positive. So we get t equals 2t minus 1 equals 0. So t equals, you're going to add 1, divide by 2. So it's 1/2. And then you get t equals negative 1. So our 4 solutions are negative 3/2, negative 1, 1/2, and 1. So there we go. Okay, so that concludes the lesson for 3.2. Go to My Math Lab, complete your exercise there, and I'll see you next time.